In example 4, we're going to evaluate the trig function of any angle. Okay, so in example 4 says find the exact value of each trig expression. In letter A, we have tangent 5 pi over 3. Okay, first step is to draw the angle in standard position. Okay, so I'm going to go ahead and draw the x and the y axis. Okay. Now, this is radians, and so 180 degrees is pi. Remember, as a fraction with denominator 3 is 3 pi over 3. Okay. 1 revolution is 2 pi, and 2 pi as a fraction with denominator 3 is 6 pi over 3. Okay. So 5 pi over 3, okay, is 2/3 of the way between 3 pi over 3 and 6 pi over 3. So here we would have 4 pi over 3, and here we'd have 5 pi over 3. So my angle sketched in standard position. The initial side is on the positive x-axis. The terminal side lies in quadrant 4, and this angle is 5 pi over 3. Now, you're going to be tempted to want to change 5 pi over 3 to degrees, but if the problem is given in radians, we have to answer in radians. Okay. Now, step 2 is we're going to find the reference angle theta. Okay, so keep in mind the terminal side is at 5 pi over 3. My reference angle theta prime is the difference between 5 pi over 3 and 6 pi over 3, which is pi over 3. Okay, so theta prime is pi over 3. Now, this angle is going to go inside of a right triangle. So what I'm going to do, from the terminal side of my angle, I'm going to draw a vertical line to the x-axis. And my reference angle, theta prime, is going to be the angle inside of my triangle. Okay, pi over 3. Now, what I'm going to do is I'm going to change pi over 3 to degrees. Okay, so pi over 3 can be changed to degrees by multiplying by 180 degrees over pi. Okay, pi's cancel, and 180 degrees divided by 3 is 60 degrees. So understand, pi over 3 is 60 degrees, which means I have a 30, 60, 90 degree triangle. And the ratio of sides in a 30, 60, 90 degree triangle is 1 to radical 3 to 2. Okay. If pi over 3 is 60 degrees, then that means the side opposite is the long leg, which is radical 3. My hypotenuse is 2. This would have to be my 30 degree angle, so the side opposite is the short leg is 1. So I have side lengths 1 to radical 3 to 2, because no matter what lengths I would actually be given, it always simplifies to 1 to radical 3 to 2. Now I want to find the tangent of this angle. Okay, so tangent, remember, is y over x, or opposite over adjacent. Okay, the opposite side is radical 3, and the adjacent side is 1. Now, my answer is very close to being correct, but it's actually wrong. Okay, the reason my answer is incorrect is because I did not take into consideration which of those side lengths could potentially be negative. And I'm looking at my horizontal side and my vertical side. So from the origin, I went right 1. That's positive. But I go down radical 3, which means this should be negative radical 3. Okay. So my tangent of 5 pi over 3 is negative radical 3 over 1, which is equal to negative radical 3. Okay, letter B. Letter B, we have the sine of 5 pi over 6. Okay, first thing I'm going to do is draw the angle in standard position. Okay, So I have 0 and I have pi. Now, with the denominator 6, pi is equivalent to 6 pi over 6. Okay. Which means the top half of the coordinate plane is divided into 6 equal parts. So I have 1 pi over 6, 2 pi over 6, 3 pi over 6, 4 pi over 6, 5 pi over 6, 6 pi over 6. So my angle in standard position is located in quadrant 2 at 5 pi over 6. Okay, step number 2 is to find the reference angle. Okay, again, this angle is 5 pi over 6. The reference angle is the angle between the terminal side and the x-axis. So I'm going to take the difference, 6 pi over 6 minus 5 pi over 6 is pi over 6. So I'm going to draw my triangle straight down, and my angle is pi over 6. Now let's go ahead and convert pi over 6 to degrees. So pi over 6 times 180 over pi. Pi's cancel. 180 divided by 6 is 30 degrees. So pi over 6 is a 30-degree angle. So again, I have a 30, 60, 90-degree special triangle. So the side opposite 30 is the short leg. That's 1. Okay, that means the horizontal side, the adjacent side, is my long leg. That's radical 3. And my hypotenuse is 2. Now, double check our signs. We started from the origin. I went left. So the radical 3 needs to be a negative radical 3. And I go up 1, that's positive, and my hypotenuse is always positive. So now I'm looking for the sine of 5 pi over 6. The sine is opposite over hypotenuse, or y over r. Okay, so go opposite of pi over 6, I get 1. My hypotenuse, or r value, is 2. That's already simplified, so sine 5 pi over 6 is 1/2. Okay, last problem, letter C. Go ahead and pause the video, try it on your own. When you're ready, hit play, and I'll go through it with you. Okay, secant negative 135 degrees. The first thing I need to do is draw the angle in standard position. Okay, the negative angle, so we're going to go clockwise, 0, negative 90 degrees, negative 180 degrees. So negative 135 falls halfway between negative 90 degrees and negative 180 degrees. So the initial side of my angle is on the positive x-axis. The terminal side is in quadrant 3. My reference angle theta is the angle formed by the terminal side and the x-axis. It's in quadrant 3, so I'm going to take my angle first, negative 135 degrees, and subtract negative 180 degrees, add the opposite, and this is a 45-degree angle. So my reference angle is 45 degrees. I'm going to go ahead and drop the vertical line, raise it up to the x-axis. Notice I have a 45, 45, 90-degree special triangle. Now the ratio of sides for a 45, 45, 90 triangle is 1 to 1 to radical 2. Okay. So I have 1, and I have radical 2. Now check to see if any of the sides need to be negative. So starting from the origin, I move left 1, so the horizontal side is negative. From here I go down 1, so the vertical side is negative, and the hypotenuse is always positive. Okay, secant is the reciprocal of cosine, so it'll be r over x, or the hypotenuse to the adjacent side. So that's radical 2 over negative 1, which is equal to negative radical 2.